All right, let's take a look at modeling data today. So correlation, in this particular case, is talking about a relationship between two variables. And we have a correlation coefficient. So our correlation coefficient is called R. And what that does is it is a measurement of how well our model fits a set of data. And we're going to be doing linear regression today. For the linear model, the range of R, is from -1 to 1. And when we're looking at a linear model, which we're going to be doing today, if R is close to 1, that indicates a strong positive linear correlation between the variables x and y. If, on the other hand, R is very close to -1, if R is close to -1, that indicates a strong negative linear correlation between the variables x and y. If our R value is close to 0 on either the positive or negative side, that indicates a weak or not a linear correlation, a weak or no linear correlation. So we're going to be finding the R values and using them to determine how well our model, our line of best fit, works. Okay? So in your calculator, this right here, this is a formula for R, and your calculator has it programmed in already. It's programmed in. So we're just going to do one by hand, so that you can kind of see how it works. And then we will also do some with our calculator. Looking at these scatter plots down here, you can see, I hope, this one, if I were going to draw the line of best fit, I would kind of draw a line right straight through the middle as close as I could. And you can see that these points are grouped right around that line. So I would suspect that this R value would be close to 1 because this is a positive slope. If we went over here, on the other hand, maybe our line looks something like that. These are much more spread out. They're not tightly grouped like on this right side. And they also have a negative slope. So this, correlation is probably, it's not real close to -1, but it should be on the negative side. It's not as a strong grouping as on this one over here, but it's still relatively, sloping negative. All right, so that's like an overview of correlation, and we're using the correlation coefficient R. The other thing we're going to be looking at is least squares regression line. And so again, this is a regression line that is looking for the best fit linear model. Okay, so this was going to help us find the best fit. We will do some by hand and some with the calculator. The ones we do by hand, we're just going to use 4 points. That's all we're going to use. And so we'll fill out this table, which we'll learn how to do in the next slide. We'll fill out the table, and then we will use those numbers to fill out our system of equations. Yay, we get to solve system of equations. Sounds fun. So that's what we're going to do with the least squares regression line. And we will also use our calculator today for both of those things. Okay, so that's an overview of what we're doing today. Let's go ahead and get into the examples. So the first example that we're going to do is we're going to find the least squares regression line for those 4 points. Okay, so let's fill out our table. So notice that this, this column is all the x values, this column is all the y values. So let's just do that first. All right, so I have a -3. I've got a -1, 0, and 2. And of course, we need to match those points up. It'd be -3, 0, -1, 1, 0, 2, and 2, 3. So those are our 4 points that we're using. Pretty straightforward to put it in the table. Then we're supposed to add up all of the x's. So -3 plus -1 plus 2. That gives us what? A negative 2. So this is sum x is negative 2. Okay, now let's add all the y values. 0 plus 1 plus 2 plus 3, that is 6. Okay, so the sum of our y values is 6. Okay, great. The next column wants us to multiply the x times the y. So negative 3 times 0 is 0. Negative 1 times 1 is negative 1. 0 times 2 is 0. 2 times 3 is 6. Then we are supposed to add those numbers up. So 0 plus negative 1 plus 0 plus 6, that gives me what? A 5. So sum xy is a 5. Okay, so not too bad, right? Just step by step. Now they want us to take all of the x values and square them. So negative 3 times negative 3 is 9. Negative 1 times negative 1 is 1. 0 times 0 is 0. And 2 times 2 is 4. And now we're supposed to add these together. So 9 plus 1 plus 0 plus 4 is 14. So that is sum x squared. So why are we doing this? We are doing this so that we could substitute those numbers into this formula over here. This is certainly not anything you have to memorize. You would be given this formula. We just need to know how to use it. So we're going to take those numbers and substitute them in. We're going to create a system of equations to solve. All right, so N stands for the number of points. So N is the number of points. Okay, so in this case, there are 4 points that we're using. So 4b plus sum x was negative 2, so negative 2a, and we're supposed to equal sum y. Sum y was 6. Okay, so that is our first equation. The second equation starts out with sum x. Let's see, what was that? That was a negative 2. And then plus sum x squared was 14. And sum xy is 5. All right, so we got all the numbers that we needed off of that table. Now it's just a matter of solving the system of equations. I think what I would like to do is take this second equation and I'm going to multiply it by 2 so that I can use the elimination method and add those two together. All right, so I'm going to copy the first one down, 4b minus 2a equals 6. And then I'm going to multiply this second one by 2. So 2 times negative 2 is negative 4. 2 times 14 is what, 28? And 2 times 5 is 10. Okay, so we add those together. That goes away. That gives us, what, 26a equals 16. So a is 16 over 26, or reduced 8/13. Okay, great. That's what a is. You might want to know, well, why do we even care about what a is? What does that even mean? What is a and b? Well, a and b are the letters that they're using in our regression model, ax plus b. So that's our regression model that we're using, and we just found a, which in the model is the slope. Okay, so then the next thing to do is simply plug in a back into one of those equations to find b. I'm going to use the top equation, it just seems easier. So 4b minus 2 times 8/13 equals 6. Let's see, so what is that? 2 times 8, so I have 4b, 2 times 8 is what, 16, minus 16 over 13 equals 6. So what do we want to do? We want to add 16/13 to both sides. Okay, so let's see, so we have 6 times 13. We need to get the common denominator. Oh, that sounds like so much fun, doesn't it? You're like, oh, sure, Dr. Wright. Okay, so we're going to do 6 times 13. That gives us 78. So we have 4b equals 16 over 13 plus 78 over 13. 6 is 78 over 13. Okay, so we add those together. What do we get? So 4b equals, we've got 78 plus 16 would be what, 94? And then I need to solve for b, so I multiply both sides by 1/4. And I will get b equals 47 over 26. Ooh, that looks fun. 47 over 26. Okay, so let's write our line of best fit. So it's y equals 8/13 x plus 47 over 26. Okay. So that's an example that we did by hand, just using our chart and our formula. Right. And of course, we used our calculator for number crunching. So the second part of this is just finding the correlation coefficient, R, for what we just did, the thing that we just did. So, okay, let's just involves plugging in numbers. We got this. So n is 4. Sum xy was 5. Sum x is a -2. Sum y is 6. Okay, excellent. We got the numerator. Denominator is under a radical. Okay, that's fine. N again is 4. Sum x squared is 14. And then sum x squared, so that's -2 squared. We need to make that a little shorter. We have 2 radicals under there. Oh, we are doubly blessed, right? So I've got a 4 for n. Sum y squared. Ooh, we don't have that one yet. Okay, why don't we create, just for this particular at finding the r, let's put a little column right in the middle here. We'll call this one y squared, because they want us to actually add up the y squareds. Okay, well, we can do that. So 0 times 0 is 0, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. So let's add those up. 1 plus 4 plus 9, what is that? That's 14. So sum y squared is 14. Okay, great. So let's just slide that 14 in there. Minus sum y was 6 squared. Okay. So 4 times 5 is 20. 2 times 6 is 12. 20 plus 12 is what? 32. And then we've got, of course, I'm doing a calculator with this. 4 times 14 minus 4 is going to give me the square root of 52. And then 4 times 14 minus 36 gives me the square root of 20. All right, making that, if we reduce that, remember my lovely factor tree, so 4 times 5, this is what, 26 times 2, 2 times 13. So I have these guys are a pair, and then of course 4 is a perfect square. So my final answer, well, the next reduced radical, I would have the 13 times the 5 left underneath the radical, which is 65, and then the 2 squared and the 2 squared, which is 4, left out, which would be 4. Lots of numbers, huh? 32 fourths is 8. So my correlation coefficient is 8 over root 65. Now, who even knows what that decimal is? Really, we want a decimal so that we can get a good approximation. So, of course, we would have a calculator. 0.99227. Well, let me write that better. 99227. Ooh, that's very close to 1. Very close, and it's positive. So that means that our equation that we just wrote right here has a very strong positive correlation. So this is a strong positive correlation. So we found a really good line of best fit. All right, so that's doing everything by hand. We will do some problems like this, but we'll do some on the calculator. So what I would like to do is we're going to take this same data and we're going to enter it into our calculator. And we're going to let our calculator do all of this for us. There is something to be said for knowing what our calculator is doing, not just, blindly punching buttons. So we now know how the calculator is finding our R and finding our least squares regression line. So now let's let the calculator do it, just so we know how to do that. So we're going to go to our calculator and we're going to go to number 4. We're going to put our data in the list or spreadsheet. Remember, we hit the tab to go up here and name it. So this is going to be my X coordinate, and I'm just going to put 3 X's. Remember, we talked about that before, where it really is beneficial to put at least 3 letters when you're naming things. And I'm going to make this one where I put my Y values. Okay. So let's go over here. We're going to enter those points. Let's see, that point was -3. Then the next X value was a -1. Then we had a 0. Then we have a 2. Okay, so let's go back up here and let's put our Y's in. So our first Y value was 0, then 1, then 2, and then 3. Okay, great. So all we need for this document is to insert the data. That's all we use the document number 4 for, is just to insert the data. To do our calculations, we need to open another document. So if you recall, it's Control Doc. We're opening another document, and this one is the calculator document. We're going to do some calculations in here. All right, so we do Menu. We're going to go to number 6, which is Statistics. And we're going to do some stat calculations. And what we're going to do is that linear regression, we had ours written mx plus b. It doesn't really matter. You're going to get the same thing. Let's just do y equals mx plus b because that's how we had ours written. Okay, so here we go. Our x list, remember you have to go over here to this arrow and then highlight, well, the x list I named, x. And then the Y list, okay? And then this is just where it's going to put our, once it calculates our line, it's going to put it in F1. So I'm just going to tab down here to just, okay it. So, all right, so let's write this down. So our slope is 0.6154. Our B is 1.8077. And our R is 0.9923. So let's put these numbers on our other sheet over here. All right, so let me just minimize this for a bit. Okay. So we've got, let's see, our M is 0.6154. So M equals 0.6154 for y equals mx plus b. And then let's see, our b was 1.8077. Okay, if you are curious, you can take these fractions right here and make them into decimals, and that's what you're going to get right over here that the calculator just did. And then our R was 0.99227. And what did our calculator get? 0.9923, so it rounded. Okay, so our calculator did the same things that we did with its little calculator brain. So of course, obviously, if we're going to use a calculator, I would give you a bunch of different points, right? More than 4. So in this particular case, since we're doing it by hand, we're only going to have 4. And we can use our calculator to check. All right.